Correlation and regression analysis, it is all about two areas. At one point, we shall be discussing about the correlation analysis. At another point, we shall be talking about the regression analysis. So to start with, let us talk about the correlation. 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 Correlation, before you write, let me explain that correlation, it is the measure of the interrelationship between two or more variables. It is actually two variables. The interrelationship between two variables. How two variables are related to each other. So when I'm talking about two variables here, I'm talking about two things. Like, for example, you have things like income, and the other side is about the expenditure. You want to find out when income increases, what happens to the expenditures. Another case is about the price and the demand. When the price increases or decreases, what happens to the level of demand? The other case can be something like advertising and sales. What happens when you make a lot of advertising to the sales? To the sales. This is all about correlation. You want to measure the interrelationship between two variables. If one increases, what happens to the other? If one decreases, what happens to the other? So the two variables here that we are talking about, it is those variables we call independent, which is normally denoted by X, and the dependent variables, which is normally denoted by Y. If you adjust the X, what will happen to the Y? So in this case, like for example, income, price, and advertising, this will be our X, the independent. And then these X values, once they are adjusted, they will cause an impact to the Y, which is now the dependent variable. In simple terms, these variables depends on this. The amount of money that you spend depends on the income. The amount of demand that will be witnessed depends on the price of the commodities. And I think you can remember that from the role of demand. As price decreases, demand increases. So what happens here? As sales here will be affected by the advertising. The more we advertise, the more we sell. The less the advertising, the less the sales. So these variables that are affected by this, they are known as the dependent. In simple terms, they depend on this. And these ones, the ones that once they are adjusted, will cause an adjustment to the other ones. We call them the independent variables. So the measure as to how the two variables are interrelated is now what we call the correlation. Is what we call the correlation. Then here we have the types of correlation. Correlation can either be positive or it can be negative. The correlation can either be positive or negative. Positive correlation exists where increase in X results into increase in Y. Decrease in X results to decrease in Y, meaning that the X and the Y variables, they move on the same direction. You increase income, expenditures also increase. That is a positive correlation. You reduce income, expenditures also reduce. That is also positive correlation. As long as they are moving in the same direction. You increase the X, the Y also increases. You reduce the X, the y also reduces. That is said to be a positive correlation. Negative correlation, on the other hand, will occur where increase in x results into decrease in y. A good example is price and demand. You increase price, the demand will reduce. You reduce price, demand increases. That is negative correlation. One, the x is reduced, the y increases. Two, the x is increased, the y decreases. So they move in the opposite direction. That kind of a correlation, we call it negative correlation. The correlation coefficient, ranges from -1 to +1. The correlation coefficient ranges from -1 to +1. The highest correlation that can exist is a correlation of +1. The lowest correlation that can exist is a correlation of -1. That is what we call the correlation coefficient, where -1 simply means perfect. Negative correlation. +1 means perfect positive correlation. So in between -1 and the +1, we have 0. 0 means no correlation. No correlation. If I can explain this, when they are perfect positive and perfect negative, it simply means that they change at the same magnitude. Like, for example, if it is a perfect negative correlation, simply means that you reduce the price by half, the demand will increase by half. That is perfect. The level at which you reduce the x, it affects the other variable, which is now the dependent variable, by the same magnitude. You increase the price by 2, the demand reduces by 2 or by half. That is what we call perfect. When it is perfect positive on the other side, you increase income times 2, the expenditure increases times 2 by the same magnitude. That is a perfect positive correlation. When there is no correlation, it simply means that as you adjust your x, the value does not change. The value of y, that is, remains unchanged. So you cannot be able to tell whether it is a positive or negative correlation. That is a case whereby we normally say that the correlation is 0. So, in a nutshell, the level of correlation, when it comes to the level of correlation, we can have it like a numbering, whereby we have said the highest can be +1, the lowest is a -1. In between -1 and +1, we have 0. Where +1, we call this one the perfect positive correlation. This one means no correlation. This one means perfect negative correlation. Again, in between 0 and -1, we have -0.5. In between +1 and 0, we have +0.5. So, in between +1 and this is a high positive correlation. If the correlation is between +0.5 and +1, that is a +0.6, 0.7, 0.75, 0.82. If the value ranges from here, it simply tells you that there is a high positive correlation between the two variables. When it is between this, means that it is a low. This is a low positive correlation. This is a low negative correlation. This is a high negative correlation. These are the correlation coefficients. And this table is very good for you to have it, because in an examination scenario, anytime you are asked about calculating correlation, the next question would be interpret your answer. And this is the chart that you will use to interpret your answer. Like, for example, you calculate your correlation and you find it, for example, it is 0.64. 0.64 is here in the region of high positive correlation. Then you would simply comment and say that there is a high positive correlation between, for example, income and what? Expenditure. If you calculate and you find that your answer is negative, for example, 7.5, negative means that your answer is here. There is a high negative correlation between the said variables that you are using to calculate the correlation. So this table is very important for you to have it. So as you are having that, I've been sharing with you the notes. So don't worry. So correlation can be highest positive, highest negative one. You cannot calculate your answer, find it beyond this. You cannot calculate correlation to find it is 2. It cannot be there. It must be an answer between these two extreme values. Now, the next question is, how do we determine the level of correlation? How do we determine the level of correlation? Correlation is calculated or determined using 3 methods. I hope you have captured that. Then we can go to the methods of estimating correlation. At what time do you want to break, Adam? Adam?
35.
And you are breaking for how many minutes?
5 minutes, madam.
Okay. Once it is at 5, I'll give you 5 minutes for prayer.
Thank you.
So if this table is with you, I want now to take you through methods of determining or calculating correlation. So the first method we normally call it the scatter. The scatter diagrams. The scatter diagrams. Scatter diagrams. The scatter diagrams occurs where you plot the values of X and Y on a graph paper, but you don't join the points to make a line. Like, for example, you can be told that this is the price versus the demand. We know the price will be our X, the demand will be our Y. So you are given the values of X. Maybe the price of a product is 15, 20, 25, and 30. When the price is 15, we demand 100 units. When the price is 20, the demand goes to 80. When the price is 25, maybe the demand is 60. And when the price is 30, the number of units demanded is 40. These are the values of X with the corresponding values of Y. And if you are told now to plot a scatter diagram using this information, It is a matter of having your x-axis here and your y-axis. Then you plot this. So you can have your 0, 5, 10, 15, 20, 25, and then 30. That is your x-axis where the values of x are captured. On the y, you will have your y-axis, you have your y values. So this is, for example, 20, 40, 60, 80, and 100, these values. So when the x is 15, the y is 100. When x is 20, y is 80. When x is 25, your y is 60. And your x is 30, your y is 40. So 30 and 40 somewhere there. So you just plot the points like that. And then after plotting, you can be able to tell the level of correlation. So immediately after the 5 minutes break, I'm going to come and then explain further on that. So Adan, you have your 5 minutes starting now. So I was trying to explain how we come up with a scatter diagram. Anytime you draw a graph and you find that your graph is having that kind of a slope, then that slope is negative. This is a negative gradient. But anytime you draw a graph and you find that your line is behaving like that, this is a positive gradient. So to determine the level of correlation, it is going to be depicted by how these points are behaving. If they are behaving like this, that tells you that this is a negative correlation. Between what? Between price and the demand. But if you plot your points and you find that they are having a kind of trend like that, then it simply means that they are having a positive correlation. And we say whether positive or negative, we have got different categories. This one, negative can either be perfect negative, low negative, or high negative. The same case, we can have a correlation whereby we have a perfect positive, high positive, or low positive, depending on how these points behave. So I want you to draw this, the scatter diagrams, to illustrate different levels of correlation. So we shall start with the perfect positive. Perfect positive correlation. This will occur when you plot your points. This is your x and your y, and you find that the points are sloping positively and they appear to be on a straight line. Remember, scatter diagram, we don't join those points with a line. You just plot them and then you observe the pattern of those points. If you find that they are sloping positively and all those points are on a straight line, then you can say that the two variables are having a perfect positive relation. B, it is a high positive correlation. A high positive correlation, you'll find that your points will behave like this. They are behaving positively because it's actually a positive correlation. But the points don't appear to be making a straight line, but they are almost making a straight line. Almost making a straight line, but not a straight line. But you can be able to observe that they are having a positive gradient. They are actually sloping like that. So it is a positive correlation, but not perfect. This is the perfect one where the points are on a straight line. These ones, they are almost on a straight line, but not a straight line, but you can tell that it is a positive correlation. Then C, we have a low positive correlation. A low positive correlation, which occurs when the points are showing a positive a positive gradient. They are showing a positive gradient, but those points don't appear to be making a straight line. They are far away from making a straight line. For example, you have the point behaving like this. They show that there is a positive trend, but those points are far away from making a straight line. This is a low positive correlation. Then D, it is when you have no correlation. No correlation will occur when the values of X and Y, you cannot tell where they are sloping to. They appear to be making a circle or a square. They are scattered somewhere. You don't know whether they are sloping that way or this way. That means that those two variables don't have any correlation. Then E, it is the low, now negative. Low negative correlation. The points are having a negative slope, but they are far away from making a straight line negative. That is a low negative correlation. Then F, it is a high negative correlation. A high negative correlation. The points are having a negative correlation, not a straight line, but almost a straight line. They are almost falling on a straight line, but not really a straight line, but negatively sloping. That is a high negative kind of correlation. Then lastly, G, it is the perfect positive, perfect negative, sorry. The perfect negative correlation. The Y and the X, they are negatively sloping and they appear to be making a straight line. This is a perfect negative correlation. So to measure or to determine the level of correlation using the scatter diagram, you plot the points and then you observe the pattern that the points are exhibiting. That one will tell you the type of correlation that exists between the two variables. So in an examination, you can be provided a table with X and Y as we had for the price and the demand. Then you are told you draw a scatter diagram. At the back of your answer booklet, you have a graph page. You draw and then you observe the pattern, and then you can be able to comment on the level of correlation that exists between the two variables based on these illustrations. That is on scatter diagrams. Then we go to the method number 2. Number 1 is scatter diagram. I've shown you how to draw them. The method number 2, which is the Carl-Pearson or the Spearman correlation coefficient, which now involves using a formula to calculate the level of correlation. If you have drawn those illustrations, you can allow me to grab the board. Hope you are done. Method number 2, we call it Carl-Pearson or Pearman. Correlation calculating the Carl-Pearson or Pearman correlation coefficient. So it can also be known as the Spearman. I think I've talked about it. Or also sometimes they can call it the Pearson's correlation coefficient. So any of those terms can be used interchangeably. In this case now, we are determining the level of correlation through calculation. You calculate, and we say by calculation, your correlation should have values ranging from +1 to -1. So you can be able to determine the answer here, and then the answer that you get will be able to give you the level of correlation because I gave you the number right from highest, which is the perfect positive, to the lowest perfect negative, and in between here we have zero correlation and all that. So you calculate, you get a figure which will be an answer between +1 and -1, and then you can put it on the scale, and then you tell the level of correlation that exists between the two variables. It is known as the Carl-Pearson or the Spearman's correlation coefficient. So in this case, this one is normally denoted as R, small r. That correlation coefficient is normally denoted by small r, and that R is calculated by N times summation of xy minus summation of x times summation of y divided by a square root of n summation of x squared minus summation of x into bracket squared times the square root of n summation of y squared minus summation of y into bracket squared.
Mwalimu, nimepotea, sitakudanganya. Na nilipotea hapo juu kwa
Yes.
denoted. Hapo kwa it's denoted as R. I'm lost. Can you go back through the
R is
calculation? What is R? Let's go there.
R is what you are calculating. You are calculating Carl-Pearson correlation coefficient. The correlation coefficient yenye tuna calculate ndio inakuwa denoted by R. This is what we are looking for.
So we are
The
looking for
correlation
R.
what? Coefficient.
Okay.
Yes, the correlation coefficient, the level of correlation.
So let's go now. R is equal to step by step. Kindly, I'm requesting. N, the letter
Yes,
N.
I'm
Yeah?
there.
Yeah, I'm seeing N. Yeah. And then that summation here.
Yes, this sign here. This sign means the sum.
It's sum.
The sum of x, y, x times y.
So you say N. The
Minus.
sum. So what do you mean N? Then the sum
Yes,
of
this
x,
is
y.
N times.
What is N?
N is the number of elements.
N is the number of elements.
N is the number of pairs.
Oh, okay.
Data points.
That means just remember where we started from. We started by saying that when calculating correlation, we measure the level of interrelationship between two variables. One of those variables is denoted by x, which is now the independent, and the other variable is denoted by y, which is known as the dependent. So that is where we started.
Yes, that's where we started.
Yes, so when I'm saying x, I simply mean the value of the independent. I told you, like, for example, if you have the price versus the demand, we have, for example, the income versus the expenditure. We have, for example, advertising and sales. I told you these are variables, but now when it is calculation, we denote them by X and Y. These ones, they are affecting this. Demand is affected by the price. These ones, we call them Y. The whole of this, whatever we have here. Demand is a dependent. This is what we call dependent variables.
Okay.
Demand depends on price. Expenditure depends on income. Sales depends on advertising. So all these are denoted by Y. Then here, these values are known as X. They are known as the independent variables. In any question that will be tested, lazima wakupatie table ya X na Y, where X can be any of these plus many others. These are not the list. We can have many things. You can talk about the employee, for example, experience and productivity. You can talk about what? The sales experience and the level of sales. So you can have so many things that you can be asked, but you must be given an X variable and a Y variable. So you can be given in form of a table. You are given here sales, like what we had on the other side. You are given the price, and here you are given the demand. So you will be given in table form. So this, for example, I started by having like what? The price is 20, 100. When it is 30, for example, it goes to 80. When it is 40, it goes to 60. When it is 60, maybe it goes to 40. These values, we call them X, because the price, it is an independent variable. These values, we call them Y, because these are the dependent. Demand depends on price. I hope up to that point we are together. So when we talk about N, here we are talking about the number of pairs. Like here we have got 4 pairs. We just count 1, 2, 3, 4. 20, 100, 30, 80, 40, 60. These are the pairs of X and Y. N. So you simply count the number of rows that you have. It will give you the N. When we are talking about XY, for you to be able to calculate here, then it means that you have a column for XY. Where XY, it is simply X times Y. You will take the value of X times the value of Y to get XY, which will be what? 2000. That is 20 times 100. When it is 30 times 80, the XY will be 2400. When it is 40 and 60, it will be another 2400. When it is 60 and 40, it is another 2400. Just an illustration. So XY simply means for every value of X, you multiply by the corresponding value of Y. And then you will be adding them. If you add these all the X, unapata the sum of X. If you add all the Y's, you will get the sum of Y. If you add all the XY's, you get the sum of XY. Then you shall also proceed and get a column for X squared and Y squared, whereby the X squared simply means you go to the values of X and square them. 20 squared gives you 400. 30 squared gives you 900. 40 squared gives you 1600. 60 squared gives you 3600. That is the X squared. So you add the X squared to get the sum of X squared. This is what you have, you need here. Here you need Y squared, the sum of Y squared. First of all, before you get to the sum of Y squared, you must get the Y squared. The Y's are here. You square them. 10 squared will be 10,000. 80 squared will be 6,400. 60 squared will be 600. This one will be 1,600. You will add them to get the sum of Y squared. These summations are the ones now that you are going to come and place them here. So when I'm talking about N, summation of X, Y, I'm simply talking about N times summation of Y squared. So like, for example, our n here is 4. We had 1, 2, 3, 4 pairs of x and y. So I'll come here and say n summation of x, y would be equal to 4 times the summation of x, y. Let me just say this is what? This is 8,000 plus 1,200. This is like, for example, 9,200. The sum here is 9,200. Just for illustration, I'll take n summation of xy is the same as n times summation of xy, where summation of xy is 9,200, our n is 4, the pairs. Then you come here, summation of x times summation of y. You take the sum of x, you multiply by the sum of y here to be able to get that. So this is the formula. But the question must provide you with a table of x and y. Your work as a student or as a candidate is to create these 3 additional columns. X, y, whereby you shall be multiplying every value of x and every value of y like that. Then you add them. X squared, you go to the values of x, you square each one of them. Y squared, you go to the values of y, you square each one of them. Then at the bottom there, you should be doing the summation for each and every column. Then the totals now, you will transfer and place them in the formula. Are we together, Millicent? Millicent, are you there?
I'm trying.
You have to. But
I'm
we
trying.
shall-
I'm not lie to you. I got lost when we reached the square roots, but I'm hoping I'll survive.
That is a formula. We don't have other.
I will help her out later. This is her
Sorry?
husband listening. I'm also watching. I will help her with it later. Okay. I understand it. Okay. So I will help her review it. Okay.
Okay, thank you. Anyway, that is it. I don't know whether the materials that I shared with somebody, they were also shared on the wall,
Yes, I shared it.
the past paper.
I shared. Whoever doesn't have, they were in the group I shared. The
Yes.
introduction and the syllabus.
Yes. Okay. Those are the past paper questions that have been tested, and it will be very appropriate if we use them for our classwork here. I want us to do one question, and then you can be able to understand how easy it is.
You have not shared. Are you saying sharing test papers? That one I've not seen. I only
I'm
have the
not-
introduction.
I tried to share, and then I was told that only the admins can share. So I shared with the.
But if you can share, you shared with somebody. Let me ask who you shared to. Maybe Kirago, our class admin.
I think I shared with Irene. The name
Oh,
was
Irene.
Irene.
Let me see. Okay, maybe she'll share it. I've not seen it. But let's proceed. Sorry.
Let me see. So there is this question. There is this question here. It is a question that was tested. I don't know the year. This question 2B. that says that the following information shows the number of years of experience of the and the corresponding number of units produced by employees of a company in a certain month. So we are given the table. One, we have the number of years of experience, the units produced. So an employee with 16 years of experience can produce 54. An employee with 22 years of experience produce 56 units. 7 years of experience, 59 and all that. And then you are told to calculate the Pearson's or the Pearson's coefficient of correlation. Then part 2, interpret the results in Roman 1 above. So it is like that. This is how the question will be tested. You will be given the two values. Now it is upon you to know which one is X and which one is Y. So the Y is always the one that is depending on the other. Obviously, you will agree with me that the number of units that will be produced depends on the number of years of experience. So the number of years of experience, they are the ones which are now making a determinant on the units. So these are the X values, these are the Y values. Then let me copy the table. We do it. So the number of the years of experience will be my X, where we have 16, 22, 7, 30, 44, 53, 23, 53 times 26. Those are the X, the years of experience. Then the units will be my Y, which is 54, 56, 59, 44, 49, 30, 54, and 44. Just wanted to copy that table before I take you to the board. So this is the years of experience. Will be my X. These are the units, which will be my Y. And then I told you to be able to calculate this correlation coefficient, your work is very simple. You need XY. You need the XY so that you can sum them. So have a column for XY. You need a column of X is already here. A column for Y is already here. What else do we need? We need X squared. We also need Y squared. That is all. Then you now take your calculator. That's why I was saying this unit requires you to have a calculator always. I'll come here and say XY simply means X times Y. So I'll be taking 16 times 54. You get 864. 22 times 56. 1232. 7 times 59. 413. 30 times 44. 1320. 44 times 49. 21, 56, 53 times 30. You get 1590. Then you have 10 times 54 will be 540. 26 times 44. 1144. You are done with XYs. XY, you take the X times the Y for all those pairs. You go to X squared, you come to the column of X, and then you square each and every value. Like here, we have 16 squared, which is 256. 22 squared, which is 484. 7 squared is 49. That squared will be 900. 44 squared, 1936. 53 squared, 2809. 10 squared will be 100. Then we have 26 squared, which is 676. You are done. You go to the y squared, you go to the column of y and square every value. You start with 54 squared, place the answer there. 2916. 56 squared, 31, 36. 59 squared, 34, 81. 44 squared is 21, 56 here. 49 squared, 2401. That squared is 900. 54 squared will be the same as this, 2916. 44 squared, 1936. That's that. So the most important thing is to just remember the formula. Then you know that the x and the y values will be given in the question. So to you, you will only add this three xy so that you can get here, x squared so that you can get this, and y squared so that you can get this. And then I will show you how you insert them in the formula. So then you add all these columns. Add them. Add them. Starting with x, 16 plus 22 plus 7 plus 30 plus 44 plus 53 plus 10 plus 26. You get it is 208. That is simply the sum of x. You sum the values of y, 54 plus 56 plus 59 plus 44 plus 49 plus 30 plus 54 plus 44. You get the 90. You go to xy, you sum all of them so that you can get the sum of xy. 864 plus 1232 plus 413 plus 1320 plus 2156 plus 1590 plus 540 plus 1144. You get 9,269. You go ahead and add the x squared so that you can get the sum of x squared. 256 plus 484 plus 49 plus 900 plus 1936 plus 2809 plus 100 plus 676. You get 7210. Get the summation of y squared to get that. Plus 2156 plus 2401 plus 900 plus 2916 plus 1936. That one looks out. I don't know why. Let me repeat. 2916 plus that one, that's 6 plus 3481 plus 2156 plus 2401 plus 900 plus 2916 19 plus 19, 19, 8, 19, 8, 42. Once you have done that, it is now a matter of now coming and replacing the values that we have in the formula. So here we know our n, the number of pairs. It is 1, 2, 3, 4, 5, 6, 7, 8. Our n is 8. So our r would be equal to, you take n, which is 8, you multiply by the sum of xy, where the sum of xy is 9259. Then you minus the sum of x times the sum of y. The sum of x is 208 times 390. You divide by, you take the square root, n, which remains to be 8, times the sum of x squared, which is 7210, minus the sum of x into brackets. There is a very big difference here between the sum of x squared and the sum of x into bracket squared. The sum of x into bracket squared, you will go to the sum of x, which is 208, and then you square it. So it is going to be minus 208 squared. Multiply by, take another square root. Now consider the y's. N, which is 8, times y squared. Your y squared is 19842. Minus, you take the sum of y. The sum of y in this case is 390, and square it. So what are you going to get? Now you just work out 8 times 9259. 8 times 9259, you get 74. 072 minus 208 times 390. You get 81, 120. Divide by the square root. 8 times 72, 10. 57, 680 minus 208 squared. 43, 264. This one you multiply by, take another square root. We are now on this side. 8 times 19, 840. 19, 842, not 840. To get it is 15, 158, 736 minus 390 squared. 152, 100. Then when you are there now, you are almost done. You take this minus this. 74,072 minus 81, 120. You get that it is negative 7048. Divide by we have got 2 square roots here. You take this 57,680 minus this. 43,264. You get 144 16. This minus this, 158, 736 minus 152, 100, you get 66, 36. So this one will be 70, 48 negative, divide by, if you take the square root of this, you get it is 120.067 times the square root of this. You get 81.462. Then the final answer will be negative 70, 48 divided by this times this. Which is 9,708.898. So get me now the value of R. You simply divide. $70, 48 negative divided by 9780.898. You get the answer is negative 0.72. And that is your R. You agree with me that it is a bit long, but it is understandable and it can be doable. It is understandable and doable. So it is a matter of understanding how you arrange your work. Once you are presented with a table, these 3 columns, you are the ones who is going to create them. You create them, then you get the sum. Once you have these summations down here, they are the ones now that you are going to substitute here, because here it is all about the summation. The summation means the totals, the total of x, y. So you must have the x, y's, then you total them. The total of x, you have the x values, you total them. The total of y, you go to the column of y, you total them. These totals are the ones that we call the summations, and they are the ones that are substituted in this formula to get the correlation coefficient. And we say the correlation coefficient, the highest can be +1 up to -1. So you can be able to see our answer is -0.72. It is within this range. You need now to go to the table and make an interpretation of what this correlation means. Correlation of -0.72. One, it is a negative. Is it high negative, low negative, or perfect negative? If you can phrase it on the number line that we drew, you find that it is going to be niambie ile number line yenye tulichora pale, from perfect positive to perfect negative. You will agree with me, this will be a high negative kind of correlation. There is a high negative correlation that exists. So your interpretation, I'm talking about the answer for this part. The answer for this part too. Interpret the results in one above after you have calculated the Pearson coefficient of correlation, and we have found it to be -0.72. And the interpretation here would be there is a high negative correlation between the number of years of experience and the units produced. The highest negative correlation, then you quote these 2 variables between the number of years of experience and the units produced. And when it is a high negative correlation, it simply means that With a lot of experience, it does not mean that you are going to have more units to produce or you are going to produce more units. That is what it means. High number of experience in terms of years does not result into high production, because you can see actually, which is true, a person with 16 years of experience can produce 54 units. But look here, there is a person with 26 years, but he only produces 44. So the years of experience is not a determining factor on the number of units the person is going to produce. That's why they are negative. Actually, if they are positive, then it means that high number of years of experience translates to high number of units being produced. But this is the opposite. Somebody with 7 years produces 59, but somebody with that years of experience producing 44. So there is no positive correlation between the experience and the units a person will produce. So I want to look for another one, but this one I'll give you as a homework. Yes, there is another one here about the advertising costs and the sales revenue. The same procedure should be followed. Come up with this table. These are the X and this is the Y. Then you introduce XY, X squared, Y squared. Get the summations, put those summations in the formula. Then you proceed and calculate this correlation coefficient, and then you interpret the answer depending on what you will get. That is what we call the correlation coefficient. So if you have the past papers, you will scroll to where you have this page 15. Page 15, question 3B. Page 15, question 3B. Alternatively, you can locate this paper. This is an examination of November 2018, question 3B. But the easiest, because the past papers are the same ones, you scroll down on your screen where there is page 15. Look at that question 3B. You answer that question. Then when we meet next week, I'm going to review that question by doing it in class. Then I can be able to see whether you have understood that before we go to the next or the last method of determining correlation. So unless there is a question, I'll stop there. I don't want to give you a lot of information that will confuse you. Just go ahead and try that. You will find it how easy it is. Use the formula. Don't be scared by N and the summations. These summations is simply the total them. And that is what those signs mean. And then you will be home and dry. I review that in our next class, if that is okay. Any question, class? Any question? So if there is no question, the class rep, you will make sure that all the members of the group, you also make me an admin so that I can be able to share resources there, so that it can be easy for everyone. So I want to wish you a very good evening. Enjoy your evenings. Bye-bye.
Bye. Thank you.
Perfect for everyone. You are free to exit. You are free to exit. You are welcome, Dehena.